Guys, good evening.
Good evening.
Hello. So screen is visible, right?
Yes,
Hello,
ma'am.
hello. Good evening, ma'am.
Yes, ma'am.
Yeah. So now let us start. Though I think
Good
I
evening,
have
ma'am.
already joined. So I think it is getting waiting from my side. Yes. So today's agenda visible now online.
Yes, madam. Visible.
No, ma'am.
See, somebody is saying no, somebody is saying yes. Okay.
Yes, ma'am.
Screen sharing is not showing now.
Yeah. I'm sharing.
Ganesh Ullendula.
No, actually, it is not allowing me to share. That is the reason I'm trying multiple times. Wait a minute. It is denying. Let me try again. Maybe any network issue. Let me check it. Visible, no, guys? Now?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
So today's agenda is 14/10/25. So we are working on Verilog introduction. Verilog introduction. So what do you know about the Verilog? What is Verilog? It is Verilog. It is a hardware. Very good. It is HTL, right? HTL, hardware descriptional language. Language. Why we need this? Why we need Verilog?
Ganesh Ullendula.
Why we need Verilog? So to develop the or create or implement any terminology is correct here. So to develop or create or implement the digital circuits, right? Digital circuits. So for designing purpose, Verilog is not only for the design purpose, we are also using for the simulation purpose, which means that verification part. We are implementing the design using the Verilog HTL, and we are developing design. After developing, we are checking the design, how it is working by doing the implementing the Testbench. Then that is called verification, right? Design and verification. So who invented this one? Who developed it? Or else, who developed it? It's Verilog HTL. How many types of hardware description languages? Types of HTLs? I think we know there are two. Yeah, tell me.
Two types, ma'am.
One is Verilog. Yeah, one is Verilog. Other one is
With SystemVerilog.
VHDL.
System
VHDL.
Verilog is HVL. Somebody is saying that is HVL. System Verilog is the HVL. HVL stands for what? Verification line. Okay. So we are just verifying. We are just whatever the design RTL is providing for us. RTL design verification engineer, some design they are providing. We are just only implementing the test wells to check the design how it is working in the system Verilog. That is not the HDL. Okay. Hardware verification plan. Verification language. Language. So this is IEEE standard, right? HDLs are from the IEEE. I think still students are joining. Like automatically they are getting in, or I need to give the permission. The admin will give. So if you guys have any doubts after the session, after the third session, you can raise your hand and ask. Okay. In between session, it's not required.
Ma'am.
Yeah, that is what I said. Okay, after the session, you can, or else you can post in the chat box. Okay, somebody is saying. So now this is the IEEE standard. Yeah.
Hello, ma'am.
Yeah, what happened, all of you?
What is the difference between Verilog and VHDL, ma'am?
So this is the same way we are implementing, but here VHDL is like a more description is there. You have to describe the code more. Here we are using the more constructs than the Verilog. VHDL is it doesn't have those many constructs, like how many constructs Verilog is providing. So we don't have that one. But here you have to write more coding part. Okay, theoretically, I mean, like the description part is fine. More description will be there. Nowadays, nobody is using. Some government companies are means their requirement is they're working on the VHDLs only. Mostly nowadays we are using for the case of designs, we are approaching with a Verilog. Okay. So now Verilog. Verilog has more constructs. Still students are joining. Into I hope everybody join. For joining, I think it is taking 10 minutes of time. Right? Wait a minute, guys. I'm just making them to let in. Okay. I think every student is joining now. That's the reason I'm, yeah. I hope we can start now. Still. So you guys can put focus on the Verilog only, because in our course we'll be going to learn on Verilog, right? So this is part of the Verilog introduction. Okay. I think you guys can start joining from before 5 minutes only daily. Okay. Whoever joined before 5 minutes, those are good. Joining late, I'm telling about them. So make sure to join before 5 minutes. The session wanted to interrupt again. So now Verilog. So by using the RTL only, right? These are comes under RTL. What is RTL?
Register transistor logic.
Okay, logic or level.
ನೋಡ್ರಾ?
What is a part of your digital? What is the difference between combinational circuits? Combinational circuits.
Combination
Sequential. Still students are joining, guys. Girish. Okay. Supriya. Guys, you can start joining before 5 minutes only. Whoever joining very late. So it's almost 7. 5:15. Sanjeev, Supriya, whoever joined late. No, you guys have to start joining from tomorrow onwards before 5 minutes, okay? Harshavardhan Reddy. Sequential circuits. Kirti Vasa, Madhu Pratik. Yeah. So let us continue. So what is combinational circuit? Combinational circuit means what? What are the combinational circuits?
which always depends on the
Depends-
present.
present combinational circuits. Are they able to join directly? I only have to admit every time because I'm not admin to the group, I guess.
Yeah, ma'am, we are admitting. You can continue.
So, okay. So combinational circuits, output depends on the
Present input.
present input. And sequential circuits,
Depends on.
does it have clock?
So
Does it-
combination it doesn't have clock, ma'am.
Does it have clock? No, right? It
Yes,
doesn't have. So sequential circuit, what is the, how you have explained what is combinational? Just tell me like that, output is depend on
Fast input.
only fast output. Huh?
Fast
Both
input.
fast
Present
Both.
input as well as past output.
Output
Fast
depends on
input.
present input,
Ah.
past output.
Yes, yes. So output depends on present input
In the past output.
and past output. Which means it has memory, right? Memory. And it
Yes, ma'am.
has clock as well.
Yes, ma'am.
What is simulation? What do you know about the simulation? Simulation,
Verification of design.
verification. Just
Runtime.
now, whenever we started in the starting of the session, we were discussing, right? By using the HTLs, we are developing and verifying, right? So verification of the
For design.
RTL design, or else digital circuit, anything.
RTL
By
gate level
passing
network.
Yeah, we will tell. Okay, gate level is different. Okay. There are functional simulation. There are two types: functional simulation.
Functional simulation, formal
Yeah. What is the
formal
What is
verification.
formal verification? Behavior. So we are checking the formal means that one only. Okay. So we are checking the behavior of the circuits. Circuit means digital circuits. And timing simulation. Timing simulation is also there. So like delays, hash delays we are giving. Hash delay. These are the times, all are like dollar time, all the system tasks we are using, those are comes under timing simulation. So here, what is synthesizable? Synthesizable. What is synthesizable first of all?
The code which I have written can be converted into a physical components.
Code is, yeah, very good. The code is converted into whatever the code, whatever you are designing, the code is convert into gate level netlist, right?
Yes.
Netlist. End of the day, any code that has to convert into the gate level netlist before getting into the after. Why do we need the verification? These many verification we are implementing. We are using the HVLs, we are using the methodologies, and we are using the Verilog. Even though we have the Verilog, we are approaching the SystemVerilog. Even the SystemVerilog is providing the more constructs than the Verilog, we are approaching the methodologies. Why these many verifications? Why do we need these many verifications?
To make sure our design
Yes,
meets
and
requirements.
Those
So
many
design, it's the functionality.
verifications. The designing, okay, that is okay. The main purpose
And
is our
the cost effective, ma'am. And the,
To
it
make sure our
will
design
with the errors in the
design
final
constraints.
phase, it will be the cost effect will be there.
main purpose is
Cost effect, ma'am.
checking the design behavior.
Bro, the fucks are done.
Design behavior, okay. But even though we have the Verilog, why do we need the SystemVerilog? Because here, even though Verilog is providing, Verilog, here we have the 4-state variables. Verilog supports 4-state. What is meant by 4-state variables? These 4-state variables, what are the 4-state variables?
Logic 0,
Zero.
logic
So one
Yeah.
next bit.
One
Sure.
X statement.
X unknown and Z, right?
High impedance.
So, yeah, high impedance. So logic 0, logic 1 tells that whether it is true or false, right? 0 and 1, and unknown and the high impedance. High impedance. Why do we need state variables? Why do we need state variables? Why do we need state variables here? These state variables only for verification purpose, okay? Only for the simulation purpose. Simulation means verification on the end of the day, right? So these variables are only for simulation. So how do we do simulation and all verification and all? By passing the random inputs to your design. For example, half adder you are implementing. So what are the inputs of the half adder? A and B, right? A comma B. So you just concatenate, yeah. You are concatenating the A and B, you're applying the $random to that one. It's a system task is provided by the Verilog $random. So you are just applying the random values to your inputs. Then you are checking the design, how it is working by passing the inputs, right? And whatever the output you are expecting. So whatever the expectation and actual from where we are getting where we have the truth table of the A comma B. So what are the inputs of A comma B? Possible combinations are 2 power 2 is 4. So 4 possible inputs will be there in the 4 possible combinations are there in the truth table. So those many, each and every possible combination is giving you different output. So similar way, whatever we are doing the verification, so you are applying the random values to that one. So you are expecting some value to that from your truth table. And that these two we are comparing, actual values and the expected values. So if it is matching, design is successful, right? Before getting into the chip, you are doing all these things, right? Before inserting the chip. What is a chip here? Chip can be the ASIC or FPGA. So we are doing verification by applying the input, by applying the inputs, or by applying the random values to the inputs. Random values to the inputs and checking and comparing the actual and expected values. Both are matching, design is successful, right? It is fast. Otherwise, some bug is there, you just have to correct your design. Yeah, synthesizable constructs. What are the synthesizable constructs?
Always block.
Constructs. Always. Is it initially synthesizable or not?
No, it is not synthesizable.
Synthesize.
Okay.
If else is also synthesizable.
If else and case statements.
Yes.
Anything else? Parameters. Parameters are synthesizable.
Yes, ma'am. Yes.
Parameters and values. Any value, zeros and ones are also we are converting. And parameters and the case statements are we already have written. And
Assign statement. Assign.
Vectors. Yeah, assign. Yeah, very good. Assign. Vectors and arrays also. Assign statement. Assign statement. Any other? Somewhere. End of the day, how you are differentiate between the what is synthesizable and what is not synthesizable. Whatever the design is using, whatever the constructs you are writing in the design will be converted into the end of the day, you will be converted into the gate level netlist. So those are the synthesizable. Whatever the in the test bench, whatever you are writing, like initial block you can't use in the design, right? So that is not synthesizable. Non-synthesizable constructs. Initial block, initial, and any other fork join is synthesizable?
No, ma'am, it is not synthesizable.
No. So hash delay is not synthesizable. In the real time, only the
Real
delay
and time
for
also.
simulation purpose only. Only in the verification purpose, simulation purpose, we are just creating one delay and writing the delays in between the each and every possible combinations. When you apply the random values, you are using the hash delay something, right? Those are not synthesizable, as well as system task. System task are not synthesizable. System tasks. What are the system tasks? Can you guys?
Dollar display, dollar monitor.
Dollar display. The only two $, monitor.
Dollar stroke, dollar
Dollar finish.
Oh, dollar stroke. Yeah, dollar finish.
Finish, stop,
All of it. Yeah, there are.
Stop.
Okay. Yeah.
dollar size also there, right?
forever.
Dollar
Size.
anything. Dollar size is not there. Okay. If you want to differentiate any range between them, you have to use the $U random range. Okay. So dollar display, dollar size, and dollar. You know these memory sizes and all backdoor access and front door access. Have you implemented system tasks like memory write read h? When you're writing into the memory, you just have to use the system task like dollar write h or
Read message,
Yeah.
write message.
right? Dollar write mem or h. Dollar h or b. H means hexa. B means binary. Okay. Dollar read. Hexa binary. So these all are the some constructs we have collected and we have written. So these all are not synthesizable, non-synthesizable constructs, and these are the synthesizable constructs. Okay. What is the difference between reg and register?
Reg is a data type, whereas register is an
Between difference between the reg and the register. Yeah, tell me. Reg is a data type, right? It is the
data type, and
Very-
register is a flip-flop.
combination of data type. Yeah. Register.
Is a memory or flip-flop.
Yeah, correct. So it is a hardware part. Okay. It is a hardware storage element. It's like a register means a group of flip-flops. We call it as register, right? A group of flip-flops.
Do we use register in Verilog while writing code?
I told you, no, register is hardware. Explicitly, I have written it is hardware. Is it possible to write in that in the design part? No, right? So when we have written hardware, that is in the circuits. It's like a flip-flop, sorry. Group of flip-flops are called what? Register.
So we don't use the word register in coding.
Circuits, maybe. Okay. Flip-flops you are using. This is the definition. No, group of flip-flops are called the register. So, and okay, just give you an example. 3TP001. What is this?
Binary 1, 3 bits.
21 3 bits, okay. Anyone wants? Okay, this is called 3-bit flip. Okay, 3-bit register. 3-bit register. Here, how many numbers it can store? Flip-flops, right? Storage, tell me. Flip-flop storage.
7.
bit.
3 bits.
Either one.
Until
1
7.
bit, okay.
1 till 7.
1 to 7 are
1 bit.
8
either
bytes.
0 or, what is it? Either zeros or ones only, right?
Yes.
It can store either 0 or 1. In the form, how it is storing? Either 0 or 1. But we are writing in the form of a binary, okay. Okay, this is 3-bit register. So each flip-flop is taking 1 bit, right? So how to declare the vectors? Tell me. Vectors. For example, size is, everybody can do this one, size is 6. And, LSB is 3. So declare the register. I mean vectors. How do we declare it? You have to declare the data types, I will tell you. Okay. So integer vector and reg vector. I have given the size of the vector 6, LSP is 3, and you have to find it out the MSP. Can you guys declare and tell me? Name of the vector, you can take it as a data. Name of the vector, you can take it as a data, and the size is 6, and LSP is 3, and MSP is 1. You have to find it out.
Range 8 is to 3 data.
8 down to?
Down to 3 of data.
Okay. Okay. What is the MSP? What is the formula? Formula for it, size. I will provide you that one. You guys can tell size equal to, so magnitude of MSP plus LSP, right? MSP plus LSP plus 1. Is this correct? Do with that formula?
LSP plus LSP plus 1.
Yeah.
Size.
No. Yeah, tell me MSP minus or LSP?
Yes.
Here
Minus
it is minus
Yes.
LSP, right? MSP minus LSP plus 1. So magnitude, if you get the magnitude like any means unsigned numbers, signed numbers, you just have to make it, take it as a magnitude, which means that positive number only you have to take it. Even though the result is in the negative, So you have to take it as a magnitude. Yeah, Jayan. Now you can declare an element using the, for example, how to declare any register. So reg 3 down to 0. I'm not taking about that formula. I mean, this question. Simply I'm declaring and showing you. So data. So use this formula and take that question. That is not the answer for that one. Okay. Example I'm telling. So how can we declare integer vectors? This is the reg type I declared. Is it possible to declare the integer? No, right? So Verilog vectors can only supports the reg and wire type. Reg and wire type only. Yeah, tell me, somebody is asking why it won't support the integer type. Okay. So in the interviews, they may definitely ask this question. Okay, integer type may not support. They may give you the code like this. Example. So like integer 3 down to 0 W data. So what is wrong in this? They were asking like this. What is wrong in below code? Below line. They were asking like this. You have to tell integers are not supported by the, I mean, Verilogs are not, Verilog vectors are not supported by the integer. So that is done. How to declare an array?
Basically, in an array, you have to like integer, then the name of the that array, and then you have to give the bit number of bits.
Okay. I will declare one array. So for example, dynamic array. Declare dynamic array, all of you. Declare dynamic array. Can you declare in the chat box? You guys are sending, I can't able to see your chart today. Yeah, now you can able to see. Dynamic arrays are not possible. Yeah. So it is the part of the system Verilog, right? We don't have the dynamic array. Only one-dimensional array we can declare, right? Not possible. So dynamic array is not possible. Only one-dimensional array supported by Verilog.
What is dynamic array actually?
That is what. Whenever you get into the system Verilog, you can learn there. As of now, you can skip it, but just asked you whether you know the difference between the arrays or dynamic array. Just asked you. Okay. Anyway, we'll get into the system Verilog, then you can learn. Okay. And what is an array actually? Why do we require the arrays?
Collection of similar data.
Correction of? Collection
Similar
of.
data elements.
Okay. Yeah, similar data type elements, right? We have vectors, right? Why do we read again arrays? Vector also storing the elements. Collection of similar data type. Okay, so no need of declaration. Declaration.
After the another.
Yeah, Verilog arrays. Verilogs, we have arrays, right? How do we declare that?
Data type, size, and variable.
Integer, yeah, data type, the size of the array. It's like a 7 down to 0 or 9 down to 0. Anything, the size of the array, and the name of the array. So it is like a array. Is it correct or wrong?
Ma'am, I think the variable name should come before the size of the array.
Yeah, array name. Array name. Declare the array name before the size of the array. Which means that integer array of 9 down to 0 is possible. In Verilog, it is possible 9 down to 0 only. Vector type, like however you are declaring the vectors 9 down to 0, but I can't write whole elements at a time here. In the SystemVerilog, it is supported. I can it is allowing 10 elements at a time. You can write like this. That is supported by SystemVerilog. But here you have to write 9 down to 0. So what are the abstraction levels? Whenever we want to implement the Verilog, right? Verilog course, HTLs. So we have some level of abstractions. Level of abstractions. Abstraction levels are else.
Behavioral, structural,
Abstraction
Data flow.
levels. Okay, data flow. Data flow modeling. Other
Ma'am,
one.
what is the meaning of abstraction level?
structural, and
So I told you that whatever the style you want to implement, the HTLs, how you want to design your Verilog course and all. Okay, that is called abstraction. Okay, that is what I'm writing here. So data flow, behavioral style. How you want to, which style you want to implement your, whether you are using the gates or using the HVLs like higher level languages, or using the data flow modeling style, Boolean expression you are writing. So those are called abstraction levels. Okay, are you getting behavioral modeling? And then
Structural level and the switch level.
structural and gate are both are same. Okay,
Yeah,
gate
gate.
at the switch level, and we are not bothered about the switch level. Backend students may have to take care of that one because they are working on the PMOSes and NMOSes. So switch level. Only. This is not related to Verilog. So NMOS, PMOS, NMOS. So up to 4 here we are using. Okay, gate level. So then what is data flow modeling style? What is data flow?
we use assign statements.
So okay, we use assign statement is correct. We use assign statements.
Parallel execution.
Parallel execution. So data flow means yeah, correct. So we need Boolean expressions here. We need Boolean expressions. So it is telling that data flow is telling that how data is flowing in between the circuits. Okay, gates. How data is flowing. Flowing means passing in between in the circuit or else in the circuit. So for that we require the assign statements, and for example, if you are implementing the AND gate, so assign equals to A and B. Okay. Let me turn on. Let's give you one. So A and B. This is A and B, right? And we implemented the Boolean expression. We assigned the A and B to the Y. Here LHS behaves like a, it's like a wire. It must be the wire here. In the Verilog, whenever you are using the assign statement, wires. What is wire? Verilog wire.
It's a connection
Wires are
between
It drives the output.
For
It's
continuous
continuous.
assignment.
continuously driven, right? Yeah, continuous assignment or else. Continuous assignment, we use wires. It must be the wire only. Whenever you are using the assign statement, LHS must be the wire type. Okay, and RHS can be the wire or else RHS can be wire or
Reg.
reg. Anything. Okay, anything it is possible. So what is reg we already have discussed above. So no need of discussing again. So wires are continuously driven. So then going to the behavioral style. It tells that behavior of the circuit. Behavior of the circuit. So how design is working, how behavior is working. What happened? RHS, Sanjay. Yeah, we need a truth table here. So anyway, to get the Boolean expression, we require the truth table, right? And here it tells the behavior of the circuit. For example, if selection equal to 0, 2 cross 1 marks, you can tell me for this behavior how we have to write. If selection is 0, selection equal to 0, what will be the output? Y equal to
Y
I0.
I0.
Else Y equal to
I1.
I1. So this is called behavioral style. How it is working, we are telling. Here we are using the Boolean expression and we are not telling, it is not bothered about the functionality of your design. Okay, but it is bothered about the functionality. How it has to work, you are describing here. And how elements are passing in the circuit, you are describing here. So in the Boolean expression, just telling, you are assigning just values, right? What is A value, what is B value, you are doing ANDing with the A and B, and you are assigning a driving to the Y here. But here you are just telling the behavior of your circuit, marks 2 cross 1, how it is working. You are describing it. Output must be reg type. Very good. So output must be reg. You told that output must be reg, but why? Answer it. Why we have to declare output as a reg type in the behavioral style?
In behavioral modeling, we use always blocks, which it typically converts into a flip-flop. So we need to store the value. So output must be a rich type.
Very nice. So always block, wherever you are using the always block, it is like a sensitivity list. Whenever you are passing the star, if it is a combinational circuit, you are passing the star in between as a sensitivity list. If it is a sequential circuits, clock is there, you are passing the posits of the clock. So here, whenever all the sensitivity is changing, so every time it keeps on changing, the output is changing. Every time it has to hold it, right? The previous value. For example, at the first clock edge, we don't have the clock in the combinational, but still we are assuming like that. Or else think about the sequential only. At positive edge of the clock, my value is at t of 0, like T2, T0, T1, T2, T3, the edges names I'm telling. So at the positive first edge of the clock, my value is 0 now. And then I'm catching the until next value comes in it has to hold the previous value, right? That is the reason the output of the any flip-flop, any design, any here in the sequential circuits, whenever you are writing, so you have to declare them as a reg type. Okay. Structural. Previous values until next value comes in it. What is structural?
Design in terms of connections between gates.
Yeah. So it is a circuit like it is telling about how gates are connected. Gates or any flip-flops also. If it is sequential, flip-flops will be there. If it is gates, no, both combination, mixing. Any circuit is having the combinational of the combinational and the combination of the combinational circuits as well as the sequential circuits, right? It is telling how gates are connected in the circuit. Switch level, no need of discussion on that. So now today's agenda, it's almost 5:53. So let us implement data flow modeling style and behavioral style. If it is possible, structural also we can implement. Okay. So let us implement the code. I told you that WIMRC commands, right? Yesterday. I will paste in the chat box. I will show you that WIMRC. Let me take it. Wait. SPL half underscore adder dot b. SPL dot wim. Hello. Are we getting? Yeah. So these are the WIMRC commands. I will paste in the chat box. You guys can copy and paste it as it is. Okay. I will tell you how to do that. I will send one command also. Did you get that one? Yeah, I think now you got it, right? So you just copy and save that in the text file. Now you have to use this command, whichever the command I'm giving. I will write in the notes. SPL GVIM command. GVIM command to activate WIMRC. WIMRC. So you have to do escape mode only. Any command. I no need to explain again and again, right? Any command will work in the command mode. So shift SPL or else new tab new, you can type it. SPL tilde negative slash dot WIMRC. What happened? Somebody is saying something. You just copy, and once it is open the file for you, it's like a new tab whenever you use this command. So it will open some file here. Okay, this tab. You just copy my commands and paste it over there. Are you getting online? Or else by end of the session, we will experiment with the one student. See here, set number, syntax enable, set cursor line, and how many tab spaces when you are coding, how many tab spaces you have to give. Like that, you will have to do everything. Okay, background is light. See, my background is white color. So, right. And if you want to change anything, you can go here and syntax here. And you can convert into this color text and all. If you can see the black color or anything, if you want to change it, do it like that. Okay. Or else these are enough. Okay. As of now. So let us implement the code. So how to design the Verilog HTL. So module name. Module name is a half adder, right? Half underscore adder. So port list, in the port list you have to write A comma B comma sum comma carry. So end module. So declare the inputs. input A comma B and output. So here this is we are implementing data flow modeling. Data flow. So now outputs are sum and carry. Sum comma carry. So now I have to use the assign statement. Assign sum equal to what is the Boolean expression for the sum? A XOR
B.
we no need to explain that much of digital concepts, right? So sum carry equal to A and B.
B.
So now design is implemented in the data flow. So now you have to develop the test bench for it. So half underscore TP adder underscore TP dot V. Okay. So first you have to include the design file. Whatever you created here, that file you have to include in the top module. So you want to check it, right? You want to verify the design, whichever the design you want to verify, that you have to include by using the tick include. Okay. So tick include in the double quotes. So file name half underscore adder dot V. So now declaration of the module top and module and module. So now you have to convert all the inputs as a reg type and outputs as a wire type here. So I'm declaring A and B as a reg. As of now, you can remember like that. As going forward, you will understand why we are doing this. Okay, carry. So now you have to do the DUT instantiation. What is your DUT here? Whatever the design you are checking, design under text. The half adder is your design. What is the module name of your design? Very good. So this is the module name. This is the file name. Wherever you see the black color line, that is the file name that you have to include here. And whenever you are using the DUT instantiation, you have to take the file name of your design. This is the half adder. Half underscore adder, some instance name you can write not only DUT, you can write ABC. But for our convenience, we are writing DUT. Okay. So here I'm writing connection by position. Connection by position. What is connection by position? I'm connecting my ports of the design as well as the test bench design port. I mean test bench ports. I'm just connecting using the connection by position. There are multiple like 2-3 types are there. Connection by position, connection by name, and the implicit connections are there. So as it is a simple design, I'm just going with the connection by position. As it is, however, you are declared in the design part, same order you have to declare. Whenever you are going with the position, you just have to declare as it is only. You should not swap this order. You should not shuffle this one. A comma B, sum comma carry. However, you declared same way you have to declare here. A comma B, sum comma carry. So whenever you are implementing the connection by name, order doesn't matter here. Okay. If it is a connection by name, order doesn't matter here. Yeah. Somebody asking something. Now in the initial processing block, you have to write the values. Initial, begin and end. You have to write the values. What are the inputs here? Those values you have to type in it. A comma B, 2 variables only inputs here. So you just applying the $random system task provided by the Verilog to generate the random values, right? That is a system task. $random you apply. And after every $random you apply, just give some delay to get all the possibilities. So you have to display. Display the result. Inputs you have to print decimal. The format specifier, if you want to see the result in the decimal format, you have to use a %d. If you want to print your result in the binary format, you have to use a format specifier as a B, %b. Okay. So octal format specifier is O, like that you have to. So B equal to B. Decimal. Sum percentage D. If I give the 0D, it will avoids the, whenever you are printing the vectors, for example, 3-bit vector is there. So why we are writing 0 before the percentage D? See here. For example, there is a vector here. So reg 3 down to 0. 3 down to 0, A comma B. So my vector size is 3 down to 0 is a 4-bit vector, right? 2 4-bit vectors. A is 4-bit and B is also as well 4-bit. So what will happen if you want to see the result in the decimal format, if you won't write the 0 here, it will gives you the more space between the result and the left hand LHS part. So y equal to, it will print like this, y equal to, like this it will print. Okay. If you want to avoid the space between the result and the numbers, you just have to give the percentage. But with the only the result is in the vector forms. Okay. Otherwise, not an issue. What happened? The sum and the carry. Carry you have to print. And you want to see the y value as well, right? So sum and carry. A comma, B comma, sum comma, carry. Now design and we develop the test bench for the half. So we'll implement all the design at a time and we'll run all the codes at a time. Okay. So data flow is done now. Data flow, we develop the test bench file. And we will implement the behavioral style as well. SQL max41 dot SQL dot. So module name is max41. So what are the inputs for the 4x1 mux? I0, I1, I2, I3, right? I'm not declaring as a vector form on all our scalars only here. So I0, I1, I2, I3. What are the inputs? Selection, right?
Not S1. S1.
S0, yeah, Y. So now end module. End module. So declare the input. Input I0, I1, I2, I3. Anyway, these all are the scalar type. I can declare in the single line. Okay, selection line and the inputs of that I0. S1. Output. Output, you have to declare them as a reg type. Just now we discussed. Whenever you are implementing the behavioral style, output must be the reg type. So Y. So now we require the always block, right? Always. Can I declare block here? Mux is the multiplexer, is the combinational or sequential?
Combinational circuit, ma'am.
Combination.
Yeah, combination. So I can't pass it as a clock, right? Passage I won't allow. So star I'm putting. Star means all the possibilities, all the sensitivity list. In the sensitivity, whenever I'm passing the star means all the inputs, whatever I0 and I1 and I2, I3, S0, S1. Okay. So begin and end. So now we are writing it. So if condition I'm writing, if selection 1, S1 equal to 0 and S0 equal to 0, which means that if both are zeros, if it is 0, 0, y should get I0.
Select I not.
Yeah. Else if S1 equal to 0 and S0 equal to 1, 0. If it is I1, right? So else if one more combination. What is that? S1 equal to how much it is? 0, 0, 0, 1, 1, 0. S0 equal to 0, 1, 0. Then it could be the I2. So now else part. Else y equal to I2. Okay. So we implemented the 4x1 max using the behavioral study. So let us implement the test bench for it. Test bench is mostly for combinational circuit. Everything is similar steps only. Whatever, however, we implemented the half adder.v. So same way. Okay. So this is the max 4.1 and this for TB dot. Request to share meeting recording for future references. Yeah, there we go. So first, what is the first step I need to do? To check the design, first I need to include the file, right? Whatever the design we implemented, that need to be included here. So what is the file name? Mux41, mux41.v. So declare the module without port list, you have to declare. So end module. So change all the inputs as a reg type. What are the inputs? I0, I1, I2, I1, I2, I3, S0, S1. Okay. S1 and the wires. You can see here, whatever the wires you have there, output is a wire now. Right. So now what is the next step I was telling you? Whenever you're implementing, so after declaration of your converting the inputs as a reg and outputs as a wire type. So what is the next step you have to do? DUT instantiation, right? DUT instantiation. How to do the DUT instantiation? So mux41 design module name and the instance name. I will tell you this one. I will tell you this one as a connection by position. Connection by name. Earlier I was telling you like a connection by position, right? So whenever I'm using a connection by name, I can shuffle the order of my declaration of the ports. However, in the design, I no need to remember exactly whatever, however I declared it. Okay. If it is a smaller design, it is very easy to remember. The 4, 5 inputs are there. I mean, 4, 5 inputs are there and one in output. It is easy to remember. But whenever you go to the industry, there are multiple inputs and there are bit designs you are checking. So at that time, what you have to do, industry will prefer the connection by name only than the connection by position. So now,
Ma'am, you are not audible.
Ma'am, you're not audible.
Ma'am, you are not audible.
Yes, she lost network connection. Just wait for a few minutes. She's designing weight.
Hello guys, is it audible? I think it is an internet issue with me.
Yes, ma'am, it's audible.
You are audible, ma'am.
But I connected to the mobile now. So because it is disconnected suddenly, internet anyway, it is time is almost. Let me join through laptop. I think it is asking me to join. Wait, let me check. If I able to connect through the laptop now, I can complete that one, whatever we have started. If it is not possible, so we'll continue with the tomorrow session only. Let me try at least 5 minutes. Is it allowing me to do? Yeah. I think it is because internet is lost and connected through mobile. That's the reason. Let me try to share the screen. Screen is visible or not?
No, ma'am.
Okay.
No, ma'am.
Yeah, yeah.
No, ma'am.
Connected mobile data, guys. Internet is lost. That is the reason. Maybe it is taking time. I think it is taking time. Visible? No. Okay.
No, ma'am.
Absolutely okay. Yeah, yeah. We will wait for 5 minutes. Okay, let me share. Visible, right?
Yeah,
ma'am.
ma'am.
Yes, ma'am.
Yeah. I'm just logging off from the mobile now.
Guys, is it audible? Hello?
Yeah, ma'am.
Yes, ma'am.
Yeah.
Yes,
So
ma'am.
now I0, I1, I2 pass up. We just have to apply the random inputs to the all the inputs. Okay. S1, S0. You're concatenating all the inputs and dollar random you passed. Earlier, no, in the olden days, like early days of Verilog, early days of Verilog, this is not there. So the dollar random system task is not provided. They were using the linear test bench. Linear test bench. What is linear test bench? Every possible combinations you have to write like this. You have to I0 equal to 0, I1 equal to 0, I2 equal to 0. So I3 equal to 0, S1 equal to 0, comma S0 equal to 0. After completing of one combination, they used to maintain like this. Okay, it is difficult to write it again each and every possible combination, right? We can't check like this. This is very difficult. If it is less number of inputs, you can do all the
It's not
possible
difficult.
combinations. If it is more than 16 or 32, 100 inputs and possibilities, it is not possible to write all the combinations, right? So that is the reason this is the advanced concept. In the Verilog, they provided the dollar random. So the tool is automatically, I think it is not supporting, guys, disconnected again from the system because I connected to mobile data. So I think it is lost the internet. So let us continue it. We can continue tomorrow only. Let me tell whatever I am saying just now. So that is difficult to implement all the possible, check all the possible combinations, right? By using the linear test bench in the early days. That is the reason they provided the dollar random. So you can apply. Tool can generate automatically whatever the possible combinations according to it. It will generate it. Okay. So let us continue tomorrow. And we'll run all these codes, whatever the codes we implemented tomorrow. And we have to see the gate level. And then Verilog introduction is finished. And tomorrow we'll be going to implement the one protocol, not protocol, one project on the Verilog. As of now, do you have any doubts?
No, ma'am.
No doubts. Okay. Then I hope I can, we think we can wind up. Yeah. Thank you, everyone. We'll see tomorrow.